Hickman, and today we're going to be going over logistic growth for calculus. So you're going to be learning how to find A and B using partial fraction decomposition, and then you're going to learn how to integrate with partial fraction decomposition, and then you're going to be learning about the logistic function, which helps us to see like a sustainability on life or food or other things of that nature. So partial fraction decomposition, I'm just going to put the procedure up here. I'm not going to go through over it. Okay, first thing you want to do here, make sure so P of x is polynomials with degree P less than Q. Q of x can be written as a product of distinct linear factors such as x plus b times x plus c. Then f of x can be written as a sum of rational functions with distinct linear denominators. Okay, so that means you could break it up like this, like that, number 4. Or like this. So you see this is 2 distinct linear factors for number 3, and it's going to be equal to x plus b and x plus c, whatever one that is. Okay. So first thing you got to do, make sure the degree of the numerator is less than the degree of the denominator. If not, you're going to do long division. We will do one of those. Confirm Q of x can be written as distinct linear factors, which means, yes, it has to be factors, so it has to be factorable. If it's not a linear, if you can't get 2 linear factors, you can't do the partial fraction decomposition. Okay, so you make it like this, and then you can multiply by the least common multiple, which is going to be this. Multiply everything by that, and so that will get rid of all the fractions. Okay? So after that, you're going to have A equals A times x plus B times x plus C. So you're pretty much just crossing these two. So A times x plus C, B times x plus B. I'll show you the algebra on that. Next, to find A and B, you're going to set what, right here. So to find A, you're going to want to make this equal to negative C. So that turns 0, so you can solve for A. And to find B, you're going to have to make this a number so that would be 0, which would be negative b, so you can solve for big B. Okay, and then you just substitute the values into A and B from what you got right here. So let's do our first example, which is going to be, so we're going to be finding A and B that complete the partial fraction decomposition of f of x equals 2x plus 16, x squared plus x minus 6. Now I think this is crooked, so I apologize if my work is, it's like really crooked, but I have no idea how to fix it. Okay, well that's better. Alright, I fixed it. Yay me. Okay, so 2x plus 16. Alright, let's do right there. So right between those squares. 2x plus 16 over x squared plus x minus 6. First thing you need to do, make sure the denominator is less than, the numerator denominator is less than the denominator. Make sure the degree of the numerator, which is 1, is less than the degree of the denominator, which is 2, and it is. So now you need to see if you can put this into linear factors. So you're going to have 2x plus 16. Are there factors of 6 that are going to subtract to get 1? Yes, there is. It's going to be x plus 3 and x minus 2. So this is the 2 distinct factors we're talking about. Now you can break that up. So now that can be A over x plus 3. It does not matter which one you put for what. You'll get the same thing. Plus B over x minus 2. Okay? If you don't get the same thing, I'll be able to figure it out. But you should get the numbers at the end. Okay? Now, you're going to multiply by the least common multiple, which is going to be x plus 3 times x minus 2 for every term, because you want to get rid of these fractions. Okay? So that cancels out, and then x minus 2 cancels out there. So now you have 2x plus 16 equals A times x minus 2 plus B times x plus 3. So to find A, x needs to equal negative 3. Okay? you want to try to make this 0. So where we see x, we're going to put -3. So you got 2 plus 16 equals a minus 2 plus b plus 3. Okay, -3 plus 3 is 0. Boom, gone. Okay, so you got -6 plus 16 is 10, -5a, so a is going to equal -2. Okay, so you can go and start writing your answer. So -2 over x plus 3. Now to find b. So to find b, you got to cancel out the a, which is going to be a 2. X equals 2. So that's going to mean 2 3. Okay, so this is 2. That's 2, 2, 2. 2 minus 2 is 0. That's gone. So then you're going to have 4 plus 16 is 20. Divide by 5, b equals 4. So you're going to have plus b, 4 over x minus 2. And this is your answer right here. A equals -2, b equals 4. And there you go for that. So for the next part, we're going to use this for the next one. Okay. So this is going to be equal to -2 So now you're going to be integrating. So to integrate partial fractions, so here's our example right here. So you see it's still the 2x plus 16 over that. So we just ended right here. Now we're going to integrate them. We're going to get an integrating quotient of that, because natural log, watch out for substitution here. Anything in the denominator is that. And then here's some properties of logarithm. Don't forget the power rule. This a right here is going to go over b right there. Okay, so we're going to integrate them, and just a tip, I would split them up. So you have -2 x plus 3 dx plus 4 integral of 4 over x minus 2. You can take the constants on the outside, they don't really mean anything. Okay, this is a natural log right here. Okay, 1 over something, you got x plus 3, u equals x. Okay, so this is going to be a natural log. You have 1 over x plus 3, so that's going to be -2 ln of x plus 3 plus 4 ln of x minus 2 plus c. Now the -2 goes on top, and then this is where this can turn into parentheses, because it's going to be an even power. Even power is going to make it positive, which logs are allowed to be. Same thing over here, even power. Okay. Now you're going to do the product rule, because you're adding logarithms. And then we don't like negative exponents, so we're going to put that on the bottom. Oops. Okay, and that is your final answer. Okay? So if you have any questions, here's some log properties that I can kind of show you here. So if you have like an R, ln of A, that's going to be ln A to the R. Okay? And then that sum and difference. There's another thing I want to show you. If you wanted to do substitution here, like I'm going to just choose this one and that one. You got u equals x minus 2. du is going to equal dx. Okay? So you got your dx right there. That is going to be 1 over u, and then you get ln of u. ln of u is going to be the x minus 2. Okay, so just a quick look if you wanted to do that by substitution. Okay, next example. So this example, unlike this one, where the numerator was less than the denominator, on this next one we're going to have the numerator degree is going to be greater than the denominator degree. So we're going to be doing long division here. Okay, where's my good pen? Alright, so we got find the integral. Where am I? 3x to the 4th plus 1 over x squared minus 1 dx. Okay, this is a partial fraction, except for the numerator degree is higher than the denominator degree. So we're going to just pause on the integration, and we need to kind of break this down for us so it's easier. So we have 3x plus 1 over x squared minus 1. Okay, since this is a higher degree, you have to do long division. 3x to the 4th, and remember in long division you have to write out every single term. Okay? Right? So what you're going to do, you're going to do 3x to the 4th divided by x squared. You don't care about the 1 right yet. You're just doing this term and this term. Okay? So 3x to the 4th divided by x squared is going to be 3x squared. Now you're going to change the sign of that 3x squared to a negative and multiply by x squared minus 1. So you got negative 3x to the 4th plus 3x squared. I'm just going to put it right under the x squared term. So this is negative 3x to the 4th. I'm sorry, it is on a glare. Okay, hopefully that's better. Okay. Now you're going to do 3x squared divided by x squared, which is going to give you 3. Okay? So now you're going to have negative 3 times x squared minus 1. And you're going to get negative 3x squared plus 3. Okay. And I'll just bring that plus 1 down here. So you get 4. So this is where the partial fraction decomposition comes in, because this is going to be plus 4 over x squared minus 1. Okay? We don't need this anymore. Thank you, long division, for that. Okay, now we're going to break that up. Can you break up x squared minus 1 into linear factors? Yes, because it is a difference of squares. X minus 1. So that is going to give me an A. So just hold off on that. Equals A over x plus 1 plus B x minus 1. Multiply by the least common multiple, which is going to be x plus 1 times x minus 1 everywhere. So you're going to have 4 equals, so x plus 1 times x minus 1, the x plus 1 is going to cross out. So you have A times x minus 1 plus B, x plus 1 times x minus 1, the x minus 1 crosses out, so you have x plus 1. Now to find a, you need to make b 0. So to make that 0, you need a -1. So when x equals -1, you're going to get 4 equals a times -1 minus 1 plus b -1 plus 1. Super, that's 0. That's what we want. So you get 4 equals -2. A is going to equal to -2. To find b, you want a to cancel out. So I'm going to make x equal to +1. So that's going to be 4 equals a, 1 minus 1, which is 0, plus b, 1 plus 1. 4 equals 2b, so b equals 2. So I got my a and my b. So this is going to turn into -2 x plus 1 plus 2 x minus 1. And you can bring down this 3x squared plus 3x squared plus 3. Now you're ready to integrate. So now you get to integrate all of this. Okay? So you can split them up. These are pretty easy. So if you want to split them up, I'll go and do that. 3x squared dx plus 3dx plus -2. -2 dx over x plus 1 plus 2 dx over x minus 1. So you get x cubed plus 3x minus 2 ln of x plus 1 plus 2 ln of x minus 1. Now, I just want to say before I move on, this can have different answers right here. It depends on whether or not you want to keep that negative here. You could keep it there, or you can put in at the end. Yeah, we'll put it at the end. So we got x cubed. So you could either make this a -2, or you could just wait until later. Okay? Because honestly, if you were just looking at it, I would ignore that negative and then come back to it later. So then we got x cubed. So we're going to do the power rule of logarithms. Okay. Now we're going to do the product rule of logarithms. Something is a negative there. Yeah, I got to put that negative up here. Okay, so what you need to do, you need to put this negative over there. So change this to a positive, put the negative there. Okay. X plus 1 so your final answer is going to be x cubed plus 3x squared, that's supposed to be a plus, ln there's your final answer. So I guess rule of thumb, just don't let negatives be out in front. Okay. Alright, so next we're going to go on to the logistic function. And we're going to do it the long way first. But it will also help increase your knowledge of partial fraction decomposition and how things work out. So the logistic function. Okay, so exponential growth, so this is supposed to be dy over dt equals kp for some k is greater than 0. So if we want the growth rate to approach 0 as P approaches a maximum carrier capacity M, we can introduce a limiting factor M minus P. Okay? So on the next example, I'm going to show you how to go from dP over dt, that's supposed to be a dt, and I'm going to show you how to get here. Yes, you need to know how to do that. Okay? All right, and I'm just going to kind of go through the steps with you. The main step is, so here's your partial fraction decomposition, which you do. Okay? And then you get here. It is important that it's m minus p over p. So the binomial has to go on top. Okay? That's why we're going to be dividing by a negative. What it looks like you don't have to divide by a negative. Okay? Alright, and then you're going to get this, and then do properties logarithm, and then we're going to be able to get to that equation right here, which is the same as this equation right there. Okay, so let's go ahead and get started. So our example is this. Solve the initial value problem using partial fractions. Okay, using partial fractions means you have to do all of the work that I'm showing you right now. Okay, so let's go ahead and get started. So you're going to be doing separable differential equations. Let's move this up a little bit because I need more board. Make sure you got paper for this homework. dP over dt equals 0.123 P, and P equals 61 when T equals 0. I'm going to go ahead and make that P of 0 equals 61. Okay, this is T, that's P. Okay, just in case. So separable differential equations. So you multiply by dt on both sides. Okay, I can't integrate yet because this needs to be in terms of t. Well, I got p. So I'm going to divide p times 1,000 minus p on this side. So I'm going to have dp over p times 1,000 minus p. And that's going to equal 0.0003 dt. Integrate both sides. Trying to get away from the glare. So that's what I want to do, but I can't because I have to find what A and P is. I can't use substitution here because of that P right there, and integration by parts is not going to help me either. So I have to break that up. So let's go ahead and break that up here. So we got 1 over P times 1,000 minus P is going to give you A over P plus B over 1,000 minus P. Multiplied by the least common multiple, which is going to be P times 1,000 minus P. So that cancels out right there. P times 1,000 minus P, the P crosses out, so you got A times 1,000 minus P, and then P times 1,000 minus P, the 1,000 minus P cancels out, so you're just left with BP. Okay, to find A, X equal, P, not X, P is our independent variable, or not really. The variable we're trying to cancel out, P, needs to be 0. So I'm going to do x equals 0 to find A. So I'm going to do 1 equals A times 1,000 minus 0 plus B times 0. Super, that's gone. I don't even care about that. Okay, so then you got 1 equals 1,000. A equals 0.001. B, to find B, I need to make this 0, so P is going to have to be 1,000. So x equals 1,000 to find B, so you got 1 equals A, 1,000 minus 1,000. So that is going to make it that, excuse me. Okay. I'm back. Hi, sorry about the phone call. Plus B, 1,000. So you got 1 equals 1,000 B equals 0.001. Great, now I am sort of ready to integrate. So this is going to become 0.001 over P, that was A, dP plus 0.00, this is B, over 1,000 minus P dP, which is going to give you 0.0003 dt. Okay. Okay. Take out the 1,000. Some of you can skip these steps. I just don't want to skip these steps. So feel free to skip them if you can. Okay. So that's ln of P. And you don't have to worry about absolute value here because we're going to be working with t equals 0. Here, watch what you're doing. Do not go right into ln of 1,000 minus p, because this is a substitution right here. U is going to be 1,000 minus p. Du is going to be negative 1, because that's the derivative dp. Okay? So I need to put a negative here and a negative right here. So that's going to turn into negative 0.0001 ln. So then that's going to turn into du over u, which is going to, and then u is going to be 1,000 minus p. Okay, now this is going to seem weird, but you need to do this, okay? It might work differently if you start with one, like switch these, like 1,000 minus p and p. You can try it, see what you get. But we need this to be on top. So if we were to do put our logarithms together, we would have p over 1,000 minus p. It can't look like that. So we have to factor out a negative here and make this the negative one. I'm also going to factor out that 0.0001. So I got 0.0001. Well, it's a negative. Factoring out a negative. So that's going to be negative ln of p plus ln of 1,000 minus p. Okay? I'm going to divide by negative 0.001 on both sides. So that's going to leave me with negative ln of p plus ln of 1,000 minus p, which is going to give me negative 0.3 minus c. We don't got to divide by 0.001 there. Combine these two together. So you can look at it like this, ln of 1,000 minus p minus ln of p to do the quotient rule. Or you could do what we did on the last one. We did bring the p here, so you have p to the negative 1 times 1,000 minus p, and then the p would go on the bottom. So I'm going to do ln of 1,000 minus p minus ln of p to be able to do the quotient rule. Okay, power up by E. So this crosses out, you're left with 1,000 equals e to the negative 0.3 minus c. I'm going to split this up because you need to split it up for later. So you're going to have 1,000 over p minus p over p, which turns into 1. And this is going to be negative 0.3 times e to the negative c. Don't worry about bringing that on the bottom. We're about to get rid of that. Okay. Now I'm going to find this by putting my initial condition, which was p of 0 equals 61. Okay, so where I see t, I'm going to put, oh, that's a t right here. I always forget to put this t. There's supposed to be a t here, a t here, a t here, and a t. Okay, so t is going to be 0, p is going to be 61. So you're going to get 1,000 over 61 minus 1. That's going to be 15.393. I'm just going to do 39 is equivalent to e. So e to the 0, negative 0.3 times 0 is 1. So you get e to the negative c. Okay? Now that we found p, we're going to solve, or now that we found e to the negative c, we're going to solve for p. I know, it's just like, okay? So, I have 1,000 over p minus 1 equals, I don't want to put 15.393 after this, so I'm going to write this like it's e to the negative c times e to the negative 0.3t. I don't want my constant to be after the e. Okay, solving for p, add 1 to both sides. So you get 1,000, 1 plus 15.39 e to the negative 0.3t. Okay, and now you're just going to do an equivalent fraction. You're going to switch these two. So p is going to equal 1,000 over 1 plus 15.39 e to the negative 0.3t. Okay? Now, let me show you something. Okay. So for our next equation, we're going to be doing this. So we started right here. Kp is going to be the 0.0003. Well, you got m. M is 1,000. Okay. So this is K, P, M minus B. So our answer was M, which is 1,000, over 1 plus 15.393, which is going to be a constant number, e to the negative K, M, T. Okay? So for 27 and 29, if it says using partial fractions, you need to do that long way. It will help you later, okay? You'll say you're welcome later. Okay, I know. All right, next problem and our last problem. So we have a gorilla place. Okay. A certain wild animal preserve can support no more than 250 lowland gorillas. Okay, that's the carrying capacity, which you see right there. 28 gorillas were known to be in the preserve in 1970. Assume that the rate at which the growth of the population is blank, where t is in years. So we need an initial condition. So the initial condition is going to be 1970. And in 1970, we had 28 gorillas. So we're going to have p of 0 equals 28. So we're going to P of 0 equals 28. Remember, this is T and that's P. And then we have dP over dt equals 0.0004 P times 250 minus P. Okay, so I'm going to be using the formula that we saw right here. We're going to go straight to putting it into that form. So we got P equals M. Okay, M is right here. So it's going to be P equals 1,000 over 1 plus A E to the negative 0.0004, negative 250 times 0.0004 times C. So we got P equals M. So here, let me go and put those here so you can see. This is K. That's M right there. One plus A E to the negative, don't forget that negative right there, KP, I think it's MK. Yeah, it's MK, but 250 times 0.0004 T. So I have two unknowns. I need to find my constant. So I put in my initial condition, P of 0 equals 28. So that's going to be 28 equals 250, 1 plus A E to the negative 0.1 T, I believe it's 0.1 T. Yep, negative 0.1 T. Cross multiply, so I'm going to have 1 plus A E to the negative 0.1 T equals 250 over 28. Subtract 1 from both sides, so you get AE Oh, I'm sorry. Wait, we can make this easier. P of 0 equals 28, which means that is times 0. Okay, so that made that easier. So, yeah. So, hold on. So you don't get confused. We'll just have 28. Okay. That's better. There's a glare. Let me try to move it away. So you're going to have, so I'm just going to switch these two. So you got 1 plus A equals 250 over 28. Subtract 1, A equals 250 over 28 minus 1, and you're going to get 7.93. So your formula is going to be P. Let me make sure you can see it. P equals 250 over 1 plus 7.93 negative 0.1 T. Okay. And we're going to use that formula for the next question, where it asks, how long will it take for the gorilla population to reach the carrying capacity of the reserve? Okay, so carrying capacity, you might want to make P equal to 250. Because how long will a population take to reach carrying capacity? So it makes sense if you have 250. However, algebraically, it is not going to make sense because you're going to end up getting a 0 somewhere. Okay? So, or close to 0. So we're going to make P be 249. It's going to come out when you subtract the 1, you're going to get a 0. Like, let me show you the work here. Let me show you why you need to get close to it, but not really. So you got 241 over 249.5, great. And then you subtract 1. So if you do 1 over 1 here, you're going to get 0, which is going to set everything off. ln of 0 is 1, and then you can't really do anything else. Okay, you won't get 81 years. I already tried it. Oh, yeah, ln of 1 is 0, so that will completely undermine anything. So that's why the carrying capacity needs to be close to 250. So we're just going to use that easy number, 249.5. and you're looking for how long. Okay? I'm just going to switch those two. 1 plus 7.93 e to the negative 0.1t equals 250 over 249.5. Okay? 7.93 e to the negative 0.1t equals 250 over 249.5 minus 1. That's going to give you 0.002. Divide by 7.93 on both sides. I don't round until the end. Natural log both sides to bring the t down. So you get negative 0.1t equals ln okay, that's 2, not squared. So t is going to be ln of 0.0002 over 7.93 divided by negative 0.1t, which is going to give you 81 years. Okay, that is it. Please check email and RedWeb for your homework. Okay, all right, have a great day. Bye. Any questions? Email me.